YouTube, in this video we are going to use the half angle formulas excuse me, in order to find the sine, cosine, and tangent of u-halves given certain information up front. So that is that the cotangent of u is equal to 3 and that our angle lies between pi and 3 pi halves radians. That is, it terminates in the third quadrant. Okay. So in this video, let's go ahead and write out what we need here. We say the sine of u-halves is going to be plus or minus the root of this 1 minus cosine of the original angle over 2, whereas the cosine of u-halves is going to be plus or minus the root of 1 plus the cosine of u, the single angle over 2. And then when we find the tangent over here, we're also going to need to know the cosine and the sine of this angle u. So what this means is we're actually going to have to sketch in here what we know about this angle in the first place. That is, we know that the cotangent of this angle is 3. And we're going to have to use that to go find the sine and the cosine values of this before we can go ahead and find sine, cosine, and tangent of u-halves. We're going to need to know those. So let's go ahead and start by using our fundamental reciprocal identity, which is, if the cotangent of u is 3 over 1, then the tangent of our angle u must be 1 over 3. Furthermore, we can piece back together this angle with a sketch by acknowledging that there is a point on the terminal side of this angle u, or this, we should have been using a u here, not a theta, but on the terminal side of this angle u, where the y value is 3 and the x value is, the y value is 1 and the x value is 3. So since we know that this angle must terminate in the third quadrant, I'm going to go ahead and I'm going to sketch some angle that terminates there. And I do mean sketch the angle. So here is the angle. We'll call this the angle u. And what I know is if I were to drop an altitude from this back to the x-axis, we have some point on the terminal side in which we know the y and the x value. As a matter of fact, I know that the y value is 1 and the x value is 3. I'm going to say 1 for a y and 3 for this. The only thing that's missing here is the fact that these must both be negative, given the fact that we are in the third quadrant. So I'm going to try to scribble this in here, -1, -3 respectively. So now looking at this, we say, well, if I'm going to find, say, the sine and cosine of u, which we're going to need to know in the first place before we can go evaluate for our half angles, then let's go ahead and do this. We say that the sine value is y over r and the cosine value is x over r. And we're very familiar with what y and x are, but we don't know what our r value is. So this is going to be the square root of -1 squared plus -3 squared. In other words, we get the square root of 1 plus 9, which is the square root of 10. So at least as far as we know here, we say our y over r value would be -1 over the square root of 10. And then our cosine value here is going to be this x over r, where we have -3 over root 10. Now that we know these two values, though, what this allows us to do is to go find the sine, say, for example, of u-halves, and then the cosine of u-halves and the tangent of u-halves. But what we'll do is we'll go ahead and rewrite this here. We say plus or minus the square root of 1 minus the cosine of u all over 2, where we're just going to substitute this value for the cosine of u into this expression right there. One thing I do want to mention in this video that I did not mention in my last video, because I wanted to pay attention on just how these were used to calculate things, is this plus or minus in front here. What I do is what I want to do is make a note on this, that plus or minus, we say it depends upon which quadrant u-halves terminates in. Depends upon which quadrant u over 2 terminates in. So when I say which quadrant this terminates in, how am I going to know which quadrant it terminates in? Well, we know that u is between pi and 3 pi halves. So if it is the case that u is between these two things, 3 pi halves, then u-halves, we can split everything here by 2. I'm going to divide this all by 2. Then we would say that u-halves is going to have to lie between pi halves, which is, you want to think about it 90 degrees in degrees. And we say this is 3 pi halves divided by 2 is the same as 3 pi halves times 1 over 2. So this is 3 pi fourths. So we say that this is somewhere between 90, you can look at it in degrees, 90 and 135 degrees is where u-halves must lie. But what this means is that it's in quadrant 2. It's got to be somewhere up over between here and here is where it terminates. What that means is just this. When we solve for the sine value in this case, and I say, well, it's plus or minus out front, we're just going to keep the positive because I know that since it terminates in the second quadrant, this must be positive. And when we do our cosine right here, we're just going to put a negative out front because I know it must be negative. But as far as what we get here, this is just plug and chug. Okay, so what we end up with here is this 1 minus the cosine value all over 2, and a positive out front, explicitly a positive. So we're going to plug in this cosine value here. We get 3 over root 10. So now we've got a lot of simplifying to do here, but we get plus, and we say 1 minus. This will be a negative. Actually, we'll just put plus a plus since this is subtracting off a negative, but we get 3 root 10 over 10, and this is all over 2. We are also going to find a common denominator with our expression on the top here, so we say 10 over 10 plus 3 root 10 over 10. This is all over 2. So now we say on the top, we end up with this expression right here. We say, well, the common denominator is going to be 10, and we have 10 plus 3 root 10, and this is all over 2 over 1. So we'll multiply by the reciprocal here, and what we end up with is this final expression. We'd say, well, it would be 10 plus 3 root 10 all over 10 times now 1 over 2, which gives us a final expression of this. We would say it'd be 10 plus 3 root 10, all of that times 1, which is itself 3 root 10 times 1, all over 20. So now the beautiful thing about this is when you're dealing with half-angle formulas, if we wanted to go back and find the cosine of u halves, the thing I'll point out here is that this wouldn't have been a difference, it would have been a sum. And so all that does is it changes on our answer right here, the fact that this in here is going to be a subtraction sign instead. So we get this, we get the root of 10 minus 3 root 10 all over 20. And the fact is, because this terminates in the second quadrant, our cosine value must be negative. It's got to be an important thing here. So we say here's our sine of u halves, and our cosine of u halves, and our sine of u halves is this thing down here. So the only thing we haven't solved for yet is the tangent of u halves, and I'm slowly running out of space here, so I'm going to try to quarantine all this off here, give myself some room. But the tangent of u halves, now I can do an expression that involves, say both, the cosine and the sine, or I could do an expression that involves both cosines. Cosine is going to keep things more consistent. Out of all these expressions, though, I kind of like this one because it has a monomial divisor, and it's a little bit easier to deal with. So we say that the tangent of u halves, in this case, is going to be equal to 1 minus the cosine of u over the sine of u, where our cosine value, we're able to solve for these up front. We say that the sine of u that goes on top, or the cosine of u goes on top, is negative 3 root 10 over 10 once rationalized. And then in the basement here, we would get negative root 10 over 10. So for the sake of this video, I'm actually going to just leave it off right here and say this is the exact value. We do need to multiply by the reciprocal after finding a common denominator on the top. But you will see that you get an exact value for your tangent value. That's how you use the half-angle formulas. Cheers.